Hey, and welcome to the Parasoft stream. And we're here, Ready Player One, or Ready Player Two, depending on when this
Ready Tester One.
Ready Tester One. I love it. And look at these guys. They are looking absolutely amazing. People have been taking photos with them in the booth, in the Parasoft booth around the corner. They gave away a VR headset, was it?
An Oculus Rift.
Yep.
So how did you find Star West, guys?
Very techie.
Very techie. Okay. You see, this is where he's coming out. I must admit, I'm going to Comic-Con when I get back, and I will have to look at some tips from these guys.
There we go.
How about yourself?
I had a blast being able to do this as a PM for Parasoft. This is a lot of fun.
And of course, you're always wearing the hat. Tell us where the hat started.
You know, I started this blog, The Code Curmudgeon, I don't know, 10, 12 years ago. And I have kind of a reputation for being a bit of a curmudgeon. And I saw this like logo someone had of this old guy with this grumpy face and this hat, and I was like, I got to do that. And you can see it from the logo on my blogs and in my videos, right?
Yeah, we're gonna have to get some caricatures done of everybody. I think we got Joe on here, but maybe after this we'll get some. We're gonna have to do some joint marketing around Ready Player One. I know it was you guys originally had something maybe a little bit more Disney themed. Was that the original kind of?
We did.
Was you Obi-Wan Kenobi, or who was you aiming to be?
I was going to do Obi-Wan, and Disney came by and said, no, not on property.
Don't mess with the mouse.
No,
don't mess with the mouse.
So we changed it up real quick. We put this together in about 5 weeks.
Yeah, maybe
got
less,
everything.
actually.
Yeah. So
that's agile for you, right? That's proper agile. Bit of a thing. You also got stormtroopers, right? You'd have got a whole stack of 12 stormtroopers
and a Darth Vader from 501st Legion. Yeah.
Oh gosh,
it was going to be a lot of fun. We had fun doing this too.
Yeah, this is great. This is great, and I think that they put together a really fun presentation, right? Because it wasn't just okay, Ready Tester One, and now we have something else to talk about. It was like really integrated with the stories. So
I did see it. They were literally coming behind from the curtains and popping out at the different key scenes of the movie. And obviously, if you've even done Snow Crash, which was the first announcement of like the metaverse, then of course Spielberg launched Ready Player One, and it just blew people's mind about, well, what is the metaverse going to look like? And, how are we going to have a digitalized version of ourselves? No samurai swords in this one, but, the similar kind of thing. And then, understanding the key to maybe this soon to be digital life that we're going to be living as a separate one. I might be I might be a Jedi Knight, I'm hoping, or something like that next time. So thanks both to you guys.
Or you might sell software.
Oh yeah, I may end up just, having a large eggplant emoji. I generally have no idea, just bouncing around, handing out flyers in the metaverse.
That'd be kind of cool.
It would be, and I think we could definitely digitalize your hat as an NFT as well. I joked because we've just been in a session with Iran and our friends from Parasoft, and he's got an NFT. So Jason, who runs Test.ai, has created NFTs off all of the main tester guys, and they've all been bought. So there's a digital version of you somewhere in the world
that someone else owns.
So you don't even own yourself anymore.
You're already a slave in the virtual world.
Absolutely. So wonderful. Well, thanks you guys for joining us. We won't let you. We won't do you for the full hour. Otherwise, you will be sat there going, I know there's lots of people coming to your booth. So thank you very much for coming in and Ready Player One-ing it. And hopefully I can let you squeeze through here. And then we're going to talk about all things Parasoft. Thanks, man.
All right. Thanks, mate.
Thank
you. So back on the live stream. So Arthur, right, we've got some big announcements. The partnership, and I'm going to say thanks to Toby Marston here, even though he's probably asleep at this time, because he made it. He kind of started this so quickly, so we could be ready for this partnership for Star West, but also for the recent Forrester with Diego.
Yeah.
And there's so much complementary, right? You guys have got the best TDM solution. You've got the best enterprise grade service virtualization. You've got APIs in your veins, right? 1987 was when Parasoft was formed, and it's just grown from strength to strength. So, tell us a little bit about Parasoft, and
we're in kind of an interesting, unique position these days because we always had like one foot in this area of safety critical, right?
Yep.
In the old days, it was at the national labs, but now it's automotive, it's medical, it's aerospace, avionics, etc. And they have very specific needs, and they build things a lot like engineers, right? They plan stuff out and do it very methodically and want lots of evidence and use a very rigorous process. And on the other hand, we had tools supporting testers, and they're lightweight and web, and you move fast, right? And 100% perfection is not a goal. Like being good enough to market fast enough, right? That intersection of having the good product at the right time, and now all of these physical things, they don't just reach out to the internet a little bit, like they rely on the internet.
Yeah.
So every cool thing you use, from a thermostat to a security camera to your car, is reaching out to a monstrous ecosystem that looks like any huge enterprise application. And so being able to help someone from the UI of a goofy car screen or a mobile device or a desktop, all the way down through making sure that the software and the code on the chip has been built properly according to standards and fully tested and can be proven that you've fully tested, is really great. And then if we add that to like what Keysight has right now, we've really, No,
I love it. And I love the thermostat, IoT thermostat. I may actually have to go out and buy one after this conversation because it's such a good idea, but everything's just so connected now, right? And it's funny because whenever I remember talking about IoT maybe 5-10 years ago, right? And I was at a conference in Dublin with Paul Gerard and a few other people, and we talked about, if you connect everything, you need less, right? But the idea was everything was just connected. And that same thing, every time I drive the car and it comes up with that little coffee sign to say, take a break, kind of feels like it should just pop up a latte or something out of the dashboard and then allow me not to have to stop and pull over at the near petrol station.
Yeah.
But, I think the digital opportunities are endless, right? And you guys you've taken the embedded testing landscape to a different level, right? And I think that's where I love this synergy, which you mentioned about hardware and software, right? Keysight is, it's Hewlett and Packard back in the garage in 1939, right?
Yeah.
They were sat there, they were building the first ever test equipment, right? Which we know they sold the 200D to Disney, which is where we are today. And it was for Fantasia. So they made the first stereo sound splitting with the signal, right? And that heritage started in Silicon Valley and led to here, right? Nearly 100 years later, we're at this point now where we're still building and testing hardware and software, like you said, but now it's so much faster, right? And it's connected car, it's IoT, it's autonomous vehicles, it's hardware and software, which is critical for people's lives.
And critical for people, yes. And it's interesting because certainly 100 years ago, 60 years ago, 50 years ago, people had a pretty long expectation for a piece of hardware's value. I'm going to buy this, it's going to last me for so many years. And definitely that number has gone down. But our expectation of what that software is going to do over that lifetime has changed. I recently returned a car lease, and I don't want to mention the car company, right, and irritate somebody. But in some sense, I was frustrated that over the 3 years, the car didn't get any better.
Yeah.
Right? Like my phone's getting updates constantly, my computer's getting updates, and some of them are truly fundamental. My camera got an update that enabled bird eye autofocus. The camera didn't come with it. But the software and the firmware got updated in the camera. And suddenly my car, which has these promising, interesting ADAS features over 3 years,
nothing changed.
Didn't get one bit better. And I think that, we call it software-defined vehicle, software-defined medical device. But the hardware's whatever, right? It's the platform, and the software is what makes it interesting.
And I love that example, right? I give you two really interesting cases on there. First is a couple of weeks back, BMW announced their connected car heated seats. I don't know if you saw this, but they're doing it as a subscription, just like Netflix, right?
And not a cheap one.
Not a cheap one, no. $6 a month to have heated seats. Now, this gives you the flexibility that you, during the summer, you don't need them, so you don't pay for them, so you deactivate them. But what they're really saying is that every single car has heated seats, but they're not enabling it for you until you pay. And it's like, I like the idea, and the heated steering wheel is also a different subscription base. But, you know, part of that promise, and it's interesting because I've seen, when we talk about NFTs for a second, I've seen the idea that they're looking at NFT ownership. So if I buy the full heated seats, $400, you know, subscription, when I trade my car in, the next BMW will take the NFT across that enables me, right? Equally, just to your point, you know, I'm doing 150 successful reverses without crashing into anything, which is probably not possible for me. But then it does auto park feature, right? You enable and lock that capability. And like you said, your car surprises you because it's now got this extra feature in it, right? Which is really cool.
Yeah.
And I think we're not there yet,
No.
but we're also, it's an extra level of testing, right? So I'm going to give you an example. It's a bit of like a lease car. I took a hire car out. It was a BMW again. And I was like, oh, I'm going to connect my car to it, phone to it. So I looked at the VIN number on the side. I registered the connected car app, and I was able to do all the things I wanted. So, you know, turn the heated seats on. You know, I was able to connect it to Alexa, and then I could just say, Alexa, turn on the heating in the car. I then gave the hire car back, and then I said to the BMW engineer, I was like, oh, I can still access this 5 Series, which I can see someone driving it, and I can press the beeping button to do the horn and also, you know, flash the lights. You know, this is a bit of a security breach, right? Or even worse, I could walk into someone's house through the envelope to say, Alexa, open the car. Yeah. And, you know, suddenly, you know, you're looking at all these edge cases of IoT, connected car, connected devices, geo-fencing, all this kind of complexity, which you've got to test for, right? Yeah. And we start off with a car, and now we're looking at autonomous cars. We, you know, the radar emulator that we launched back in January, where it literally will emulate or simulate 500 objects on a screen, so you can put those edge cases of the bird flying across and not setting off the auto brake, and causing an accident, which now my 14 Pro will say, then ring the emergency services on, or my car's SOS will send the GPX information of where I was, the impact, and to emergency services. So we've got this kind of incredible ecosystem. And then I was in our Santa Rosa office literally last week, and they showed me these bees, which we've got, which are literally a Car2X system. So you put them in the car, and it talks to another car up to 5 kilometers away. So when you're driving along, of course, this car's coming very fast behind a building. Of course, the autonomous car, the Tesla autopilot, is only going to see what it can see.
Sure.
However, because they're connected, that car will stop because it knows that this car could potentially be going through a red light. And so suddenly we're seeing this connected area, and that's just cars. We then do that to Car2X and infrastructure to X. So the example I gave at my session yesterday, if you're at the traffic light, you put your foot on the accelerator, it goes green, allows you to drive. And that's what Audi have already got today, right? So connecting things together, beacons, smart thermostat cups, I used to love the Starbucks example where I used to always get off at the train at London Bridge. The geofence would set off my if that then this to say order a Starbucks, and I'd walk past Starbucks and forget that it auto ordered me a coffee. But you can kind of see where it's going. It's like there's so much technology. How do we even start testing this?
Yeah.
And how early can you start? Without things like service virtualization.
Yeah, and how much more do we have to think about unexpected usages?
Yeah.
Right? Like, because you think about the car app and you think, well, people have a car and they sync their phone and that's that. But you don't think about rental cars, lease cars, right?
Yep.
Like, go ahead.
Yeah, go for it. Yep.
But like trying to test these things, right? Like it's very problematic, especially if 2, 3, 4 organizations are all producing some stuff that's going to be ready at the same time. Look, the dirty secret of the industry, right, is that if you tell the developers that it's shipping September 1st, that the software delivery is, August 31st at 11:59 p.m. in whatever time zone the developers live in, right? Which leaves you no time for testing.
Yep.
So being able to use like virtualization and set up an entire city ecosystem inside my office, which I probably don't have traffic lights in my office. Right? Yeah, being able to like simulate these things in a cheap, lightweight way. I know that there are people that have big, giant, super cool testing labs, but we have to move past that now because now thousands or tens of thousands of developers and testers are involved in really big applications that have real consequences when they fail.
And that's really interesting. So I was at Hitachi for a number of years, and we did exactly that. We used your service virtualization, and we did we created wind turbines. We did the solar panels, and so yes, we're not going to stick a wind turbine in the test lab, right? And what do we know that the wind turbine is? Well, at the end of the day, it's an API endpoint, right? So we would send the API to say, turn on the wind turbine. And as you'd expect, it took a certain amount of time to ramp up to speed. And then it was sending the response back saying 20 watts, 20 watts, 20 watts, 19 watts, 18 watts. And so you had all of that information, which is where I think the SV component comes in to mock out that thing, which is a unique signature because it's a solar panel or it's a wind turbine. It's also got a unique set of data which you need to synthesize, right? So you need a synthetic test data generation, so you can then say, okay, this particular wind turbine is giving 40% output. This one's getting 80, and every time it gets the response beacon, it's 20, 30, 40 something. So it makes it realistic.
Yeah, and imagine the cost of having one turbine, and now you're saying, but I need 3.
Yep.
So that I can test various load balancing scenarios. Now you're like, I need this one to be good. I need this one to be bad. I need this one to fail. I need this one to get hit by a bird.
Yep.
Right? Like all those scenarios are suddenly, sure, why not?
Exactly. And we use Parasoft in that case. So we did predictive weather. So in Germany, there was something called Startwerke, which was a virtual power station, right? So what they did is they took historical information based on weather patterns, and then they were able to predict how much generation would come out of the solar panels,
sure,
and also the wind, based on historical information.
Right.
And then when they wanted to be able to buy and sell electricity efficiently, so the grid over here on a football match or a sporting event is going to use 90% of its capacity. So therefore, we need to spin up more turbines. We need to switch on these ones in these different regions because that based on the prediction. And that's so complex. You've got thousands of, of wind turbines, thousands of,
And it's everywhere from the electrical system, right? The power systems from vehicles, and also in really mundane areas that you don't think about, like you go to local 7-Eleven to buy a 6-pack of beer, and you don't realize that certain vendors have these little like smartphone apps that tell them that, oh, well, there's a big concert in town this weekend, and there's an end of summer fair coming up, and there's a this and a football game, and here's exactly how much money I can make with how many square inches, and they can enable the store owner to understand right sizing their purchase.
Yep.
Incredibly complex problem to deliver a liquid beverage.
Yeah, no. I used to work at dunnhumby, which were marketeers, right? And they had a product called Shelf Review, which I tested, and it would tell you where to position your products. And it was interesting because it had this whole thing about the higher the product is on the shelf, that the more valuable it was. So people look typically. So there's all the kind of the complexity, but it was more around allowing product experimentation, right? So I want to do a new beverage and I want you guys to do it because it's a big football match. So I do some kind of promotion. It's at the front of the store. I'm going to get an increase of X percentage.
Sure.
And it's all analytics powered, right?
Yeah.
But what was really interesting is Hitachi used to do water purification plants for Coca-Cola. And Coca-Cola was trying to do Coke as a service. It never went live, but it was literally, I've got like Netflix, I've got a subscription. So if I go into a 7-Eleven, I can grab a Coke, scan my barcode, no cost to myself, right? I also can go over to a restaurant and get that beverage as well. So the idea was, let's get people onto a subscription plan. But one of the things they were trying to do was there's a big sporting event, your favorite team, wherever it may be, and their mascot is red. So they would dye the Coca-Cola. They would put the advertisement on there. That's a limited edition Coke for the Super Bowl. And then they push those out with a very small timescale. Now, if I didn't realize that Coke actually takes something like 12 weeks to go from production to on the shelf, they've obviously got to do that 12 weeks before the sporting events. They've got to know how many people in Boston are going to buy them and what color they need. Suddenly, even a beverage in a digital landscape has got APIs, it's got endpoints, it's got, smart tools that are, doing fulfillment, doing delivery and shipping and tracking those parcel deliveries. It's incredibly complex.
Making everything far more effective, letting people really target so that your products are exactly what you want, what you need, and hopefully, like your coffee, at the moment that you want it. But all that system is very, very complex to test. And the more pieces it touches, the harder it is to test. And again, sometimes it's a wind turbine and you can't have it in your office. And sometimes it's a partner who you're using their service. Maybe it's a big credit card payment service, but they don't care about you. And if you run $1 million worth of test transactions, you might have a problem. And you can't get them necessarily to behave badly like you need. Too fast, too slow, screwed up data packets, like all the sorts of things you need to test. So virtualization is cool, and the one thing I just wanted to circle back on was the test data management, right? Because when you say it, like, people are automatically thinking traditional database driven, and we're going to feed data into our normal database system. But with virtualization, we're now talking like it's virtual data against a virtual asset. It's light, it's fast, it's cheap, and it's ungodly flexible. And now with AI ML, you take the data you have, you synthesize new data to give it maybe privacy or to give it new edge cases. You analyze what's going on, you give it new edge cases, right? The fact that we use the AI ML to train cars to drive, and now there are AIs that are looking at the images we use for training, creating edge cases to train the AI. Like, the AI is training itself by changing the training images.
I think we're into a whole new complexity level right there. And I did a book at the start of the year, artificial intelligence for software testing, right, with Rex Black. And we kind of got to this thing, and of course, talk about bias, but part of it is test data. I kind of wanted this when I was at CES this year, I was like, stop all happy path payloads. That was forget happy path testing, which is 90% of what people do. But the payloads are handcrafted, right? So it's happy path data sets that in essence are just proving very little. With TDM and synthetic data, with service virtualization and API testing, you can make sure you're getting the data coverage as well as the test coverage, right? So that becomes more realistic. And that's exactly what you're talking about, is in the real world, I've got $10 in my account. I buy a Coke. I'm now on minus 12 or something if I'm in Disneyland. But the next transaction doesn't go through. It's not just, negative testing on steroids. It is literally thinking about making sure we're trying all the permutations, which will happen in the real world.
Which will happen, exactly. And that's why things are so complicated. Because if something can happen, it will happen.
It will. And I think you also picked a really interesting trend, which we were just talking about, which was around chaos testing, site reliability engineering. AWS recently launched a fault injection system for all of their products. So if you've got Kafka, you can inject a whole stack of dummy messages at a consumer or a producer level. So it, maybe it breaks, it brings down a pod or something like that. So you can try to see how long it takes to resume, spin another instance up and get it through. I know you guys test things like Kafka and streaming services, but things are incredibly complicated, right? Moving from the old days of ESBs and TIBCO and people like that to now micro, nano services, GraphQL, which I know you guys also support, knowledge graphs. It's endless, the complexity of these systems. Exactly. And having a solution that can do your functional API testing, your test data management, your service virtualization all in one place is game changing for most people who are stuck
and
in
we
this.
can look at your definitions files, your open API spec, or your traffic, and get you up and running.
Yeah. And I think that, that's why I'm really excited about the partnership, right? Because, Keysight's heritage is hardware, right?
Right.
And, Eggplant, it kind of did a bit of a different approach to test automation, right? Image-based. So let's look at it through the eyes of the user, right? So it's great for this in the sense of, if you can see it, you can use computer vision against it. But, that modeling, that model-based testing approach really benefits from having APIs, testing APIs exhaustively, like you said, against a Swagger spec or an open test spec. Creating service virtualization for, is also really important, right? Being able to test, create that very quickly and actually be able to test against it. So you can test earlier in the life cycle. And you've got the embedded test, you've got the static code analysis capabilities. You're either now injecting Burp Suite security suites into there.
Burp and Zap, so
Zap,
free, paid, whatever, right? Like hook it up. We can literally take a tester who's never done security tests in their life, and they're 30 seconds away from running deep Zap testing for no extra money. Now, they may need to give those results to a security person to understand them, but they're now able to do something, and the security team now can just start dealing with results and not trying to figure out what test do I create. So it's really powerful.
No, I love it. And I think kind of, to me, the power when you bring the two companies together, right, is, like you said, it complements, because the way that you guys have gone within the embedded space, you've already kind of mentioned some of the complexity, healthcare, military, financial services, healthcare, whatever it may be. It's a complex domain. How do you support it? And then, bring in the knowledge in together to bring things like lifecycle virtualization, which I was talking to you guys about the other day. So combining service virtualization with network virtualization, network function virtualization, it brings the holy grail, because you can literally do synthetic app, API, service, and then down to network, PCAP kind of level. And then below that, network function virtualization we acquired a company called Scalable Networks, which create a digital twin of the entire network. So you can literally say, this is how your load balancers are doing. This is the firmware those ones are running. This is how many cores they've got, all the information to replicate and emulate those complex SDN kind of, software-defined networks. And like you said, everything now is software, but it still has hardware underneath it, right? It's still running on some kind of HAL.
We just take the hardware for granted now.
Yeah.
That's
and
the
we
difference.
expect it to just work, right?
We just expect it to work,
So, I know we're going to kind of summarize in there. It's been great to have you guys here. We did some great stuff. We've just done a session on performance engineering, which was fantastic. Have you got any kind of big tips or takeaways from, Star West you want to share with the audience?
I think that, virtualization, service virtualization, its own finally, right? Like people have often thought about, what do I do with it? I think people are now starting to realize that it's a key enabler. You're going to get to some point in your DevOps cycle and be stuck, and service virtualization is going to let you keep moving, right? There's no way you're going to be able to live without it with these big complex things we've talked about.
So I think that is a really interesting end point. Is, we're told DevOps, we're told continuous testing, we're told to do things faster. We know we need to automate, and to automate, we need the right data, we need the right services, and we want to test earlier. And, I think this is where, Parasoft, Eggplant, Keysight, better together. Really looking forward to seeing how we can, support each other in this kind of open testing alliance kind of model of how do we help our customers achieve better testing.
Completely solve their problem.
And it's as easy as that. So thank you so much for watching.
Thanks,
and thanks so much to Parasoft as well. It's been fantastic to be here from Star West. And as you can see, everyone's shutting down. So we're going to sign off, and thank you for watching.